So in this tutorial, we are going to talk about how to calculate the sensitivity and specificity of a test. So I have got a question which is saying a new diagnostic test of tuberculosis, which is TB, was compared to the gold standard PCR, and the results are shown in the table below. So look at the table. Now this table has got two parts. So we have got people who had disease and people who didn't have the disease. But then we have got the test that we have two tests. So what happened was that simple and straightforward. So we were comparing with the gold standard. So we want to see if this test that we have gotten now is going to have maybe high sensitivity, high specificity. So we have to calculate that. So if we look at this column here, I don't know if it's a column or row, but so these people had disease, then these didn't have disease. But after testing using the new method that we want to get, we discovered that 142 were tested. We are tested to say these people have got what? Disease. But again, out of the same people who had disease, but 14 people were tested negative, but they had a disease. Okay? Then now, people who didn't have a disease, after testing using a new method, we discovered that 8 people were tested positive. Then, again, 1,336 people were tested negative. That is making sense. But again, 8 people were tested negative, were tested positive, but they didn't have a disease. Then there's a problem somewhere. Okay. So now, the first question is saying, using the details in the 2 by 2 table given, calculate the following: sensitivity, specificity. We need to calculate also the positive predictive value, the negative predictive value, as well as we need to interpret the results. Okay, so now it's very important. Sometimes this table can be written in opposite. They can put disease here. Maybe they put disease positive, then they put disease negative, then they put this test here. They put here this test 1. But the most important thing that we need to understand is you need to understand this. So as long as something that is testing someone has got a disease, then the test is telling us that indeed this person has got disease. So then that is true positive. So meaning that this is true positive. I'll say TP. So it's true positive. Okay? Yeah. So another thing that we need to understand is that these people had disease, but again they were tested negative. So are those results true positive? No, those results are not true positive. So those are false negative. Okay, so then these ones now are false negative. So I'll put them here. False negative. I'll put FN. Now, people didn't have disease in the next here. People didn't have disease, but after testing them, then we found that 8 were tested positive. So they didn't have a disease, but again the results are coming out positive. So those are false positive. Yes, they are positive, but they are false. So it's FP. These are false positive. Now here, if you look at this, people didn't have disease. After we test and then we discovered, we say indeed these people didn't have disease. Definitely that is true negative. They are negative, but their negative is true. So it is true negative. So it is true negative. When you do this, anything, any table, even if they flip it, it's going to be very much easy for you to answer this question. Okay? So now, the first thing we want to find what sensitivity is. So sensitivity is just basically the ability of the test to pick up true positive. So what's the ability of this test to pick up true positive? So true positive, we are talking about this row. You see how simple it is now. We are talking about this part here, true positive. We want to see out of the things which were tested positive, which ones were indeed true positive. Okay, so sensitivity is given by the true positive divided by the true positive plus the false negative. Okay, so we are looking at these people had disease, but again we are saying that true positive sensitivity is the ability of the test to pick up positive results or true positive results. So we are looking at people who had disease, but again for people who had disease, how many people were tested to be positive out of all the people which had. So now we want to see how sensitivity this test is. So the ability of this test to pick up, to say indeed this is true positive, what is the ability of that test? So now we are looking at we are looking at this one here. So we are looking at this one. So the true sensitivity is true positive divided by true positive plus false negative. So then now we need to, it's always in percentage, so you need to do times 100%. So the true positive we have 142. Then the total they have already given us, there is no need of us struggle. So we have got true positive, which is 142, plus false negative, that is 14 times 100%. So this gives me 142. So if I add this, that is going to be 156 down there. So it's 142 divided by 156. The answer I get times 100%. So 91.02%. So I'll say 0.03 because I'll round it off. So the ability of the test to pick up true positive results is 91.03%. That would mean to say approximately about 9%. So it has got high sensitivity. We can clearly see because 91 is just too much. So it has got high sensitivity. Yeah. So the ability of the test for us to give us, for it to give us like fake results, I think it's about 9%, but less than 9%. It should be 8.0 something. Yeah. So then we also have specificity. So specificity, we are just talking about the ability of the test to pick up true negative. Okay, so people don't have disease. Now the ability of that test to tell us to say indeed this person doesn't have disease, that is now specificity. How specific this test is. Okay, so specificity is equal to the ability of the test to pick up true negative results. Okay, so that is now true negative, we divide it by the same true negative plus the false positive. So we're just looking at this row. So if you can clearly see here, we're just dealing with one thing. So quite okay, the number of people which were tested, like the number of people who didn't have the disease, there were about 1,344. Now the ability of the, now after testing, we discovered that again people didn't have disease, but 8 of them were tested positive. So that is false positive. So now for us to calculate the specificity of this test, we have to say the true negative divided by the true negative plus the false positive. The results which were coming to be true, but people are negative, okay, times 100%. So true negative is 1,336, then true negative 1,336 plus the false positive is 8, then times 100. So the total is already 1344. So you just say 1336 divided by 1344, then the answer you get times 100. So that gives me 99.4. So 99.4%. So yeah, so that is specificity. Now we need also to look at how to find the positive predictive value. So now if you look at this, nothing is complicated even if they change these things. So here I was looking, we're talking about this, we're going in this direction, but now when we're talking about positive predictive value, it's the opposite. Okay, it's the opposite. So you'll be going in this direction. We want to look at the things that were tested positive. Okay, so positive predictive value in simple terms we say PPV. So positive predictive value is given by true positive divided by true positive plus false positive. So we are looking at the positive results. Okay, positive predictive value, we are only interested for the result that gave us positive, whether diseased or undiseased. Okay, so you do times 100. So now if you look at this, we have got true positive is 142. The total, if I add this and this, the total is already given here. So in short, 142 plus 8, then you do times 100%. What will be now our positive predictive value? So it is 142, you divide it by 150, then the answer do times 100. So that is 94.67%. That is my positive predictive value. Now let us look at negative. Let me not delete this, I'll just get rid of this. Okay, now we also have what we call negative predictive value. So we call it NPP or NPV. So NPV is given by, again here, so we are looking at we are now looking at the test that gave us negative. But the test that gave us negative, indeed the people who didn't have disease, which are true negative, we have to divide it by the total of all the things that gave us negative. So meaning that it is the true negative, you divide it by the true negative plus the false negative. They were negative but they are false. Okay, so you do times 100. So if we look at this, true negative is 1336 divided by the total here is 13. When you add this, it's going to be 14 plus 1336, which is 1350. So you do times 100. Okay, so the negative predictive value will be 1336 divided by 1350. Now the answer I get times 100%, that is 98. It's 98.96 percent. Now if you look at these results for interpretation, now you have to look at this. Look at how sensitive and how specific this test is, and also look at the predictive value. Okay, but how can you interpret these results? Okay, but before we interpret, there's also another part that they like asking. They can also ask you to find what we call the prevalence. The prevalence, is it that I'm failing to write the spelling of the prevalence? So the prevalence, they can also ask you to find the prevalence. So the prevalence is you find it by just saying the total number of people with the disease. Okay, like the total number of people who indeed had the disease, and also you divide it by the total number of people who were tested. Okay, so you say the total diseased divided by the total tested, the total number of people who were tested. So if we look at our table there, we can clearly see that the people who who had disease from the table here, the people who had disease, this is the row, the total is 156. So 156 is the people who had, so you do times 100, Then the total number of people who were tested, you look at this again. The total number of people who were tested is 1500. So 1500 times 100%. So I think 0 and 0 can go. I can just say 156 divided by 15. That gives me 10.4%. So that is my prevalence. So now that means that we remember we're talking about is out of 100%. So I'll start explaining about the prevalence. So this means that 10 people out of every 100 people tested are actually having TB. That's what it means. So the prevalence just tells us to say 10 out of 100, out of every 100 that are going to be tested, they have what? TB. That's what it means. So this is not part of the question. I just wanted to explain about that. But now let's go back to this part. Now, part E is saying what is the interpretation of the sensitivity and the specificity results. So now let's interpret the results. Okay. So if we look at the sensitivity, now I no longer need this. Let us look at the sensitivity. So sensitivity, we have 91.03%. That is sensitivity. Then specificity, I would present it by P, but it's not P. It is actually 99.4. Okay. So it means that these numbers are high, because for us to pick the new test, we need to look at the sensitivity and the specificity of the test. So this 95, it means that the test has got high sensitivity and at the same time it has got high specificity, meaning that at this point we can clearly see that it is in rare situation where we're going to get false positive. Okay, so the majority of the results that are going to be detected here, they are going to be what? They are going to be true TB cases. Okay, if we look at the results here, out of 150 people who were tested, okay, out of 150 people who were tested, or let me say out of 156 people who were tested, the people who actually had disease, 142 were positive, were found out to be positive for 14, but sometimes it might be just some small errors of the same machine that you are using. So meaning that still you are going to have few false results, but the machine has got high sensitivity. So the best interpretation here that we can tell is that the test has got high specificity and high sensitivity. This means that it is in rare situation where you can give false positive. So the majority of the results are true TB cases. As simple as that. So this is how we calculate the sensitivity and specificity of the test. So in this, if you find this, then I think it is recommended for you to get that new machine. It is okay, because at least it has got high specificity and high sensitivity. Okay,